What's up everybody, my name is Eric. Welcome to my channel, Eric the Tutor. What's up everybody, my name is Eric. Welcome to my channel. Today we're going to be talking about SN2, SN1, E2, and E1. SN2, SN1, E2, and E1. So these are pretty popular and high in demand. I get a lot of questions about this. Let's go ahead and jump into it. So I'm just going to go ahead and put an example on the board and we can talk about it in more detail. Okay, so let's say we have something like this and we have KCN and they're asking what's going to happen. Well, the first thing we have to look at is we have to look at our substrate. So this is our substrate and we need to consider whether it's going to be primary, secondary, or tertiary. Now when we say that, we're talking about the carbon that is attached to our leaving group. Okay, so we need a good leaving group to start. Now when we say primary, we're saying that this is attached to just one other carbon. So this would be primary. If it had another carbon coming off, it would be secondary, and so on. So that's the first thing we want to consider. So primary, secondary, tertiary. Next we want to look at our reagent, or I like to call it our nucleophile. Okay, now we can break this down. We're going to have to generate a nice big, have a bunch of examples. You're going to make your own table, okay? So this we know is a spectator ion, and this is a Cn minus. So this looks like this. The carbon has an extra lone pair. So I know this is going to be a good nucleophile. Good nucleophile, okay? So this sets us up perfectly for SN2 conditions. SN2 conditions would like to have primary. It can do secondary with some exceptions, so I'll go ahead and put a squiggle, and it does not like to do tertiary. Okay, so this would be a good example of an SN2 attack where this came here and directly kicked this group out and gave us our final answer. Now, SN2 happens in one step. One step. We can say that this is a concerted reaction. Okay, meaning it happens in one step. We also get inversion of the stereochem. So inversion of our stereochemistry. If I have a group that's coming out of the board, our final answer is going to be our new nucleophile that has substituted the leaving group going away. Okay, so if this is coming out of the board, then this is going into the board. All right, so that's SN2 in a nutshell. Now, if we wanted to, let's compare to an SN1 style condition. Well, if we had something like, say we had this and a Br here, and we reacted this with water. Well, this has different conditions. So if I go ahead and put over here to the side, SN1, it would prefer to have tertiary. It can do secondary, again, I'll put a squiggle, and it will not do primary. Okay, so what do we have here? We have a carbon with how many neighbors? 1, 2, and 3. So that's 1, 2, and 3. This is going to give us a tertiary. Typically, we use poor nucleophiles to go ahead and undergo these reactions. And the first step in an SN1 reaction is for the leaving group to leave on its own. So now we have something that looks like this. Positive charge on that carbon. We have some Br minus floating around. So I'll put over here to the side. This is not one step, but many steps. Many steps, okay? Formation of a carbocation. So we need to form a carbocation. Carbocat. Great. Now our next step is for our nucleophile to come and actually bind directly. So this is our next step. Now we have this with our water, positively charged, Still got one lone pair now. We used one of those lone pairs to form a bond with the carbon. Now, in order to fix up that positive charge on the water, we can go ahead and take a negative charge here to grab a hydrogen and kick on a lone pair. So our final answer looks like, and we have a OH group. Okay, so that would have been an example of an SN1 style reaction. I'll go ahead and do more examples in the following videos. Thanks, guys. See you next time.